Hello, everyone, and welcome to Lecture 17 in our course on general psychology. And this will be a standalone unit. So this unit on psychoactive drugs will only consist of one lecture. So we're going to be talking about psychoactive drugs today. And of course, there are a lot of different kinds of drugs. We'll, of course, as always, define what a drug is. Uh, but we'll talk about the different kinds of drugs and how we categorize them. We'll talk about their effects on the brain. So drugs interact with neurotransmitter systems. Neurotransmitters are something we learned about in our unit on the brain. And we're going to see that the effects that drugs have on the brain, on behavior, on health, are often mediated by these neurotransmitters. That the effects of a drug are dependent on what neurotransmitter system or systems that drug affects. So in particular, we're going to also add some history in there. So some drugs are naturally occurring. They come from plants or some other natural process. And so we've known about those for quite some time, even thousands of years. So we'll talk about some of that history. There are also synthetic compounds or compounds that required advances in chemistry first. So those are newer, but they still have some history behind them. So we'll talk about the history of the drugs themselves and also a little bit about the history of drug use. Again, we'll also look at how the effects of a drug are related to the neurotransmitter or neurotransmitters that drug affects. So when we say that a drug enhances the activity of a certain neurotransmitter, the effects of taking the drug can often be guessed and guessed pretty well from knowledge of what neurotransmitters changed. And we'll look at how drugs alter physiology. So that's obviously a more physical process, as well as perception, a psychological one. So certain drugs, especially the hallucinogens, can change how we perceive the world. They can change other aspects of psychological function as well, but the hallucinogens in particular are famous for changing perception. We'll also talk about drug dependence. So long-term drug use can come at the risk of dependence. And that risk varies depending on what kind of drug you're talking about. But that dependence also comes in different forms. And there are different ways of treating different kinds of dependence. So we'll talk about that as well. So first, of course, we have to define our terms. And we need to ask, what is a psychoactive drug? And your book says that it's a chemical that influences consciousness or behavior in some way. That's a pretty good starting point. I like to add in that it somehow affects signaling in the brain. Your book has that component as well. Uh, it's often involved with specific neurotransmitters. So we have a chemical that alters something about psychological function by altering signaling in the brain, and that altered signaling is often brought about by affecting certain neurotransmitters. And there are different ways of doing that. We're not going to go into the details so much. Uh, Generally, you can either increase or mimic the level of a neurotransmitter, or you can decrease or block neurotransmitters from binding to receptors. So you can either sort of enhance a neurotransmitter's activity or decrease it. And there are certainly drugs that fall into each of those categories. One thing I like to emphasize here is that when we talk about drugs, that a chemical is a drug uh, if it influences psychological processes, uh, but it has to be taken in small amounts. And why is that important? Well, if you take large amounts of sugar, for example, so sugar can affect your physical well-being. It can affect your psychological processes. So can water, for example. You can drink lots of water, or drink uh, no water would be the opposite of that effect. But you drink lots of water, and it's going to affect how you feel. But it's not a psychoactive drug because things like water and food need to be taken in large amounts to have that sort of effect. So while sugar, while water, while other kinds of foods can affect our psychological processing, can affect how we feel, we don't consider them drugs for that reason, that they need to be taken in large quantities. And when we say drugs, it often brings up the idea of illicit drugs, like we see here. So things like marijuana, cocaine, heroin, ecstasy. These are all different drugs. We'll mention most of those. Uh, but drugs, as the definition suggests, are just chemicals. So prescription drugs, as the name suggests, are drugs as well. So really what makes these different categories not so meaningful is the fact that these are all just chemicals that affect the brain. And that is really the important definition of a drug. Legality can change. It certainly has changed in our history in this country. So calling drugs according to legal or illegal categories isn't a very useful exercise. Um, Chemical structures, the purpose of drugs, it's a little more useful. But what we're going to do here is classify different kinds of drugs by their effect. So all these things do something to the brain. They affect signaling within the brain by interacting with neurotransmitter systems. But these different kinds of drugs uh, often share effects. So that's what defines their categories. So we'll talk about things like depressants, which tend to be relaxing when you take them. They say they depress the activity in the nervous system. Stimulants do the opposite. They increase activity in the nervous system. They keep you awake. There are opioids, which is a class of drugs we're increasingly aware of in this country. Your book uses the term narcotics, and I don't use that term for the main reason being that it's not very clearly defined. And depending on who you ask, different drugs will be narcotics and other drugs won't. So technically, narcotics are drugs that put you to sleep. Um, Opioids have that effect, but they're not the only drugs that do that. And so I don't like to use narcotics for that reason. Also, legally, so there are many laws and regulations that include cocaine as a narcotic. So if you hear about law enforcement busting a narcotics ring, that can include cocaine. And cocaine does not put you to sleep at all. In fact, it's quite the opposite. And it's not even in the same family as the opioids. So narcotics is not a very good definition. Um, it's not a very good term to use. And so here I use opioids, which is what they really mean in your book. We'll get into what opioids are later on in this lecture. But I'm using opioids instead of narcotics. I think it's clearer. I think it's more precise. There are also hallucinogens, and there are a couple of famous ones in this category as well. LSD is probably the most famous, but these alter usually visual perception. They affect a different set of neurotransmitters than the stimulants do or the depressants do. So hallucinogens are their own class of drugs. Marijuana, another interesting one, and of course, here in Colorado, we are more aware recently of marijuana's legal status, of potential medical uses, for example. And so marijuana gets its own category. It doesn't, some sources will put it in with the depressants, but it has some non-depressant effects. So we're separating it out here. One category that your book doesn't mention in this chapter uh, is the psychotherapeutic drugs. That is, drugs that are intended to address a psychological disorder or disease. I mention them here because we don't want to forget about that category. So they are certainly a psychoactive drug. However, I'm also not going to talk about them in this particular lecture. They are drugs, they are psychoactive. But we're going to defer that for one of the last units in our class where we talk about psychological disorders. And so we'll build into that unit a bit on how these things are treated pharmacologically. So the first major class of drugs that we'll come to are the depressants. And these work usually by increasing the activity of the neurotransmitter GABA. If we recall from our unit on the brain and neurotransmission, GABA is our inhibitory neurotransmitter. So if you increase GABA activity by either mimicking the molecule itself or by binding to GABA receptors and acting like GABA, what what you're going to do is inhibit the nervous system. And inhibitory neurons that use GABA are fairly common. They make up about 15% of synapses in your brain. So this is a common neurotransmitter. And so depressants usually increase its effectiveness. And these are drugs like alcohol. And again, a drug is just a chemical, and it's a chemical, if it's psychoactive, that affects the brain and behavior. And alcohol, many people don't think about alcohol as a drug. They tend to think of things like cocaine or marijuana, but alcohol is a drug. It's a chemical. It affects your psychological function. The barbiturates are another type of depressant. They're not in as much use anymore. They were one of the early depressant drugs that were developed in the late 1800s. But they are a depressant. They increase GABA activity. They increase inhibition of the nervous system. So you get an overall decrease in neural activity. The benzodiazepines, of which Valium is probably the most famous, were developed in the middle of the 20th century, and they were developed really as a replacement for the barbiturates. So barbiturates are effective, but they can also be very dangerous. There's not much wiggle room, so to speak, when you're talking about the dosage of a barbiturate. So barbiturates, you need a certain dosage to have an effect, and a little more than that, and you can start to get dangerous amounts of depressant activity. And so there are a class of drugs that are easy to overdose on because the amount taken to be effective is not that different from the amount taken to be lethal. Benzodiazepines, you don't really have that problem to the same degree. You don't need nearly as much to be effective as you do to be dangerous. And so the benzodiazepines, like Valium, have largely replaced the barbiturates. Not totally, but largely. The inhalants, which is a class of drugs defined by how they're administered, which is unusual. We don't typically classify drugs by whether they're injected or ingested or inhaled. But the inhalants describe chemicals, and most drugs are not taken as an inhalant in this sense. These are often household products that can have a psychoactive effect, but that is not their intended use. So we see a diagram here in the lower right of things like spray paint, whipped cream, markers that give off fumes, and glue is a really famous one. So these are substances that are volatile chemicals. They enter the air really easily from their liquid form. And so they can be inhaled, taken into the lungs, and absorbed into the bloodstream. And these tend to be depressants as well. So they tend to have depressant-like effects. Many of them, we don't know the mechanism for it because, again, they're not developed as drugs. They're developed as household cleansers or paints or glue. And that is one of the things that makes the inhalants so dangerous, is that they are not marketed for consumption. And so there's no concept of appropriate dosage. Certainly they're not labeled with an appropriate dosage. And they're often, because they're household products, they're often taken by individuals that don't have access to other drugs, perhaps safer drugs. And these tend to be adolescents. So people that aren't old enough to consume alcohol legally, for example, are more at risk for using inhalants. And again, these can be very dangerous products because the person using them is often trying to do it secretly. There is no recommended dosage. And these inhalants often contain other toxic chemicals as well that can be dangerous. So some components are psychoactive, but some components are poisonous. And so the inhalants are a particularly dangerous category of drugs. So what do depressants tend to do? Well, they tend to reduce neural activity. So they increase the activity of GABA, either by binding the GABA receptors or via other mechanisms. They could mimic GABA, or they could perhaps not look structurally like GABA, but still bind to those receptors. But in the end, they somehow help GABA do its job. They make more of GABA, or they substitute for GABA in some way. And so they reduce neural activity. And this tends to relax people. Lower neural activity means your neurons aren't as active. You tend to be relaxed. It's easier to go to sleep, or in this case, not move so much. So they can reduce motion, reduce motor activity. And then again, they can also induce sleep if taken in sufficient quantities. The legitimate uses for depressants are often as anxiolytics, which is a term that means a drug intended to reduce anxiety. So Valium is an example of the anxiolytic properties of a benzodiazepine. Xanax is perhaps the most famous anxiolytic on the market today. You also have hypnotics, and the term hypnotic means not inducing hypnosis, but rather causing sleep. And many depressants, if taken in larger doses, will induce sleep. So just an alcohol is an example here. Alcohol, of course, is not prescribed, but alcohol, you take a little bit, and you tend to feel more relaxed, at least after a while. Alcohol has some interesting effects we'll get to in a minute. But other drugs like benzodiazepines or barbiturates, if you have a little bit, it relaxes you, reduces anxiety. If you have more than that, it can cause you to sleep. And then finally, they're often used as anticonvulsants. And anticonvulsants counteract seizures. So these are drugs that are used to treat seizure disorders, the most common of which being epilepsy. So epilepsy and disorders like it produce seizures by creating positive feedback loops of activity in the brain. So you'll have a small group of neurons that suddenly become active, and they talk to each other. They increase the activity of their neighbors. And if that goes on, then those neighbors excite their neighbors, and so on. And pretty soon you get these giant synchronized waves of activity in the brain. And so in order to keep that from happening and reducing the severity, you will often be prescribed a depressant drug to eliminate seizures, or at least make them not so severe. So you reduce neural excitability, and now those neurons communicate with one another, but you don't get that severe positive feedback loop where they really excite their neighbors. If they're not that excited in the sense of neural activity, then they tend not to produce so many seizures. So that's another medical use for depressant drugs. A little bit more on alcohol, because it's such a common drug of use, misuse, of use in our society. Historically, alcohol, of course, is a naturally occurring substance. It is the product of fermentation. So this occurs in nature naturally. You'll have fruit, for example, that has fallen off the tree starts to spoil, and microbes will start producing alcohol. And that is the product of fermentation. Of course, humans figured out how to do that artificially and intentionally, and they do that with things like yeast. So yeast takes sugar present in things like fruit, grapes, grains, and turns it into alcohol. So alcohol is the waste product of those microorganisms. And of course, alcohol has been used for thousands of years, most commonly in the forms of beer and wine, or beverages like it. Uh, when you get into the later part of the modern era, so we're talking about 1700s, 1800s, there's an increase in what's called distillation. So distillation is the process of concentrating alcohol, and that's where we get what we call liquor. So things like whiskey or vodka. So these have a higher concentration of alcohol. And of course, with that higher concentration, it becomes easier to consume too much. It becomes easier to experience the long-term effects of having too much alcohol in your system. And so starting in the 1800s, you see the rise of what are called temperance movements. And these are social movements seeking to reduce or eliminate the sale, distribution, and consumption of alcohol. Again, particularly having to do with distillation, distilled products that are more concentrated and therefore easy to overuse. Of course, in the 20th century, in the beginning of the 20th century, you have prohibition, so a ban on the production and sale of alcohol. And prohibition lasted for about 13 years before it was repealed. So it turns out that prohibition in some ways worked. It did reduce alcohol consumption, but the fact is that what happened was it drove alcohol consumption underground, and so criminal organizations took over the production of alcohol. There were fewer regulations on the quality of alcoholic beverages. People didn't seek help because they were doing something illegal. And so there were a number of negative consequences to prohibition. Also, economically, you couldn't tax something that was now illegal to sell. And so revenues went down for the government. And so a number of consequences of prohibiting alcohol led to its eventual repeal. So it lasted from 1920 to 1933. And then, of course, we know now that alcohol is legal to produce and sell as long as you're over 21. So there are still age limits on it. And more recently, if we can look at alcohol consumption over the last couple of decades, so well after Prohibition, we actually see that alcohol consumption in the U.S. at least is fairly moderate right now. So there was a big rise, we can see this diagram on the left, a big rise in the late 70s and early 80s, where people were consuming large quantities of alcohol. And this declined through the 80s and into the late 90s. So it's on the rise again to a certain degree today, but it's nowhere near as large as it was in the late 70s, our alcohol consumption. And so people talk about the rise in drug use. And certainly alcohol use and abuse is still a big problem. It's one of the most commonly abused substances that there are. But the fact is that people don't consume as much alcohol now as they did almost 40 years ago. But on a related note, we're also seeing fewer alcohol-related fatalities when it comes to car crashes. So this was a much bigger problem, I mean, still a problem, but it was a bigger problem in the late 70s and early 80s, coinciding with the rise in the use of alcohol. And it has not been eliminated, of course, but it has been reduced. And it's hard to pin down exactly why that is. Part of it could be stricter laws on drunk driving. It could be societal pressures, so pressure from peers not to drink and drive. It could be a perception of the riskiness. So a lot of fatalities do involve alcohol, but now as people learn that, perhaps they're reducing the likelihood that they'll have a few drinks and then go and drive somewhere. So a decrease in alcohol usage, also a decrease in alcohol-related car crashes. So what does alcohol do in particular? Well, we know because it's a depressant that it relaxes people. You take enough, you can go to sleep, you can lose consciousness and get alcohol poisoning if you take too much. But the psychological effects depend in large part on your expectations. And this is the idea of expectancy theory. They've done placebo studies where they give people either alcohol or a placebo and then tell them either that they consumed alcohol or not. And it turns out that their belief that they've consumed alcohol has almost as big an impact on their behavior as actually consuming alcohol. So people that haven't consumed any alcohol at all, if they're told that they've consumed a large amount of alcohol, will act drunk. And so our expectations have a lot to do with the effects of a drug. And this is not just true for alcohol. We'll see later on this is true for other drugs as well. There is the phenomenon of what's known as alcohol myopia. So alcohol is a depressant, but it also, early on in the stages of consumption, disinhibits you. So overall, it has an inhibitory effect, but behaviorally, you start doing things that you otherwise might not have done. You might express emotions that you wouldn't have expressed. You might say something that you wouldn't otherwise have said or do something that might be unsafe. And it's thought that this is due to alcohol myopia, that alcohol affects our ability to weigh short versus long-term consequences, and that suddenly short-term gains, things that seem like fun right now, uh, suddenly become more important or more attractive, and you start ignoring those long-term negative consequences. And we think this is because alcohol has an early effect on the prefrontal cortex. So it affects the whole brain eventually, but it affects the prefrontal cortex pretty quickly. And the prefrontal cortex is what keeps you in check in terms of undesirable actions. So it keeps your emotions in check. It keeps your impulses in check. So if you shut down that gatekeeper, so to speak, suddenly those emotional impulses don't have anything reining them in. Uh, Prefrontal cortex is also heavily involved in planning. And so if you eliminate that, you don't plan so well. You don't think about long-term consequences so much. So that's alcohol myopia, and it is of course a common symptom of alcohol use. In terms of what alcohol does to health, some of these are more famous. You can actually get alcohol withdrawal. We'll talk more about withdrawal symptoms later on. But withdrawal symptoms are generally the opposite of whatever the drug does. So if you get used to having the drug in your system and then suddenly take the drug away, now your brain is compensating for a chemical that's no longer there. It hasn't had time to adjust yet. So it acts like alcohol is still there and counteracts it. So instead of relaxation, you get anxiety. Instead of drowsiness, you get wakefulness. And so those withdrawal symptoms can even include, if the dependence is severe enough, seizures. And alcohol withdrawal can actually be lethal if the person is dependent enough. And so often something like a benzodiazepine, like Valium, will be administered to sort of wean the person off of alcohol while still not allowing the person to feel the full withdrawal effects. You can get physical effects as well, like cirrhosis, that is scarring of the liver, and heart disease. So alcohol can be toxic to heart muscle and to the blood vessels that surround the heart. And so you can weaken the heart and diminish its ability to move blood around the body. And of course, that is potentially fatal as well. And of course, for pregnant women, there is the risk of fetal alcohol syndrome. So fetal alcohol syndrome can occur with certainly large amounts of alcohol, but it seems that even smaller amounts can produce some of the symptoms of fetal alcohol syndrome. So the jury is still out on whether it's okay for a pregnant woman to have one drink per day. The safe course of action is, of course, not to consume alcohol at all. But fetal alcohol syndrome can be fairly severe. It's associated with developmental defects, physical defects. There's a certain characteristic facial structure. The nose tends to be flatter. The shape of the area around the lips tends to be different. The eyes are shaped differently. But more importantly, you can also have mental retardation that accompanies fetal alcohol syndrome. So again, it can be very severe, but it can also be easily avoided. Okay, our next class of drugs is the stimulants. And these are, in many ways, the opposite of the depressants. And by the way, depressant here, as stimulant is a neural term. We're not talking about the psychological disorder of depression. So if you have heard of antidepressants, those are not the opposite of depressants. Antidepressants address the disorder of depression. Depressants decrease the excitability of the nervous system. Stimulants are the opposite of depressants. They increase the excitability of the nervous system. That is to say, they increase neural activity. And some famous examples here are cocaine, we see here. Cocaine is interesting. It is actually a naturally occurring substance. It is the extract of the coca leaf, which is native to South America, and native groups in South America have been using coca leaves for hundreds and probably thousands of years. Here in this diagram, we can see the powdered form of cocaine. That form was only possible thanks to advances in chemistry in the late 19th century. Also in the late 19th century, that is the 1800s, you see development of products we call patent medicines, which are mixtures of substances that didn't really have to prove that they were effective at addressing a disease or disorder, but claimed it nevertheless. And Coca-Cola, of course, is a very famous drink now, but it started off as a patent medicine. And its chemical formulation was a little bit different back then. It started off with caffeine in it. That's not objectionable nowadays. But it did also have cocaine in it. You may have heard that about Coca-Cola. It's not true anymore. There may be some flavorings from the coca leaf that are part of Coca-Cola. The formula is, of course, secret. But cocaine is not one of those ingredients any longer. But at the very beginning, it was. Coca-Cola did contain cocaine. That's where the coca part comes from. Amphetamines are amphetamine refers to both an individual drug, a particular chemical, and a group of structurally related drugs. So the amphetamines are also stimulants, as is methamphetamine. Caffeine is another famous stimulant. It works in a pretty different way than cocaine or amphetamines do, but it does increase neural activity. And finally, nicotine. So some sources put nicotine in a separate category. Uh, your book classifies it as a stimulant, so we'll stick with that. But nicotine also works in a slightly different way. But all of these things, generally speaking, increase neural activity. And you'll notice that many of these things are naturally occurring. Amphetamines are not, they're synthetic. But cocaine comes from coca leaf. Caffeine can be found in coffee beans, but also tea leaves and chocolate. And nicotine, of course, naturally occurs in the tobacco plant, which is why tobacco is cultivated. It's not really useful for too many other purposes. So what do these drugs do in the short term? Well, you often, caffeine's an exception, you often get a sense of euphoria. So this is certainly true for cocaine and amphetamines. So euphoria is an extreme feeling of well-being, often sudden. You might even be a little lightheaded because of it. And we think this is because of stimulant effects on dopamine. Now, not all stimulants affect dopamine. Caffeine doesn't, as far as we know. And certainly not all of them affect it directly. So nicotine seems to increase dopamine levels, but sort of indirectly. Nicotine does not actually work on dopamine receptors, does not increase dopamine levels directly. It's sort of downstream effects are what causes increases in dopamine. So a lot of drugs will do this. They'll interact with certain neurons, certain neurotransmitters. But if those neurotransmitters are associated with neurons that then talk to other neurotransmitter systems, then you can have these indirect increases or decreases. But cocaine and amphetamines both affect dopamine fairly directly. So cocaine prevents reuptake of dopamine. And what that means, of course, if we refer back to our unit on how the brain works and synaptic transmission, reuptake is how neurons get neurotransmitters back into that presynaptic neuron. You have those little molecules that are vacuuming up neurotransmitter once it's released. And cocaine prevents that from happening. So dopamine is not taken back into the neuron, so it stays out there in the synapse and continues to work on the postsynaptic side. Amphetamine actually works by increasing the release of dopamine, not by preventing reuptake. Slightly different mechanism, but both work to keep dopamine levels high. And we think that's why you get this feeling of euphoria with these drugs. You also get the sense of alertness. These drugs keep you awake. And this is true for all of the stimulants. And this is primarily because of the way these drugs interact with norepinephrine, which is a neurotransmitter involved in our sympathetic nervous system. So our fight or flight response. Part of that fight or flight response is an increase in heart rate, an increase in alertness. And so these drugs that can increase norepinephrine levels, they give this sense of alertness, of wakefulness. They keep you up. And again, this is another consequence that we can infer, we probably could have guessed, just by knowing that the neurotransmitter norepinephrine is involved. These drugs can also affect mood, as well as body temperature, and these are both functions of serotonin. So cocaine in particular increases serotonin levels, in addition to keeping dopamine and norepinephrine from being pulled back into the presynaptic neuron after release. It also keeps serotonin out there in the synaptic cleft. So you have more serotonin in the cleft, it can act longer on postsynaptic receptors, and so cocaine, and to a certain degree amphetamines, increase serotonin levels. And so this causes a change in mood, usually improves mood, but also can have a dangerous consequence with regard to body temperature. Body temperature can get dangerously high. For cocaine in particular, it's interesting. Cocaine in sufficient dosage can block sodium channels. Now, if we remember from our unit on the action potential, sodium channels are necessary for neurons to send electrical impulses. And cocaine can block those sodium channels, which is why cocaine can also be used as a topical anesthetic. It can deaden nerves temporarily. By blocking sodium channels, you prevent action potentials from occurring. And this is true certainly in neurons, but it turns out heart tissue has sodium channels as well. And if you have too much cocaine in your system, you can keep the heart from working, which is why you'll sometimes read about someone who was otherwise healthy, took too much cocaine, and had a heart attack. Because cocaine, in addition to being an anesthetic, can also stop cardiac function. So there are other effects of these drugs as well. And by the way, this diagram in the lower right is an old advertisement for a cocaine product, cocaine toothache drops. So cocaine, this is before cocaine was so heavily regulated, cocaine was involved in a number of products, a number of medicinal products. And so this product in particular is emphasizing cocaine's role as an anesthetic. It could relieve toothache by deadening the gums. So some of the downsides of these drugs are that stimulants, and again, cocaine and amphetamine in particular, can actually produce symptoms of what we call psychosis. And psychosis refers to the symptoms of schizophrenia. So you can start to be paranoid. You can start to get delusions, especially paranoid delusions, where you think someone is out to harm you. You can start to get hallucinations, particularly auditory hallucinations. So you hear voices that aren't there. And we think this is because of these drugs' effect on the dopamine system. As we'll see when we get to schizophrenia, one of the symptoms of schizophrenia seems to be things like delusions, things like paranoia, things like hallucinations. And what relieves these symptoms are drugs that decrease dopamine levels. So this isn't the entire picture. We'll get into a little more detail in a later unit. But we think because cocaine and amphetamines in particular increase levels of dopamine, that you start to get some of the symptoms of schizophrenia if you take too much of these stimulants. There's some reproductive effects as well. All of these drugs, there's mixed evidence on things like miscarriage. So cocaine and amphetamines, we think, can cause premature birth. Lower birth weight is sort of a mixed bag. The evidence is still controversial on which of these things can cause low birth weight. But again, they seem to be able to cause perhaps early birth. So they have some negative reproductive effects. And of course, several of these drugs, caffeine to a lesser degree, but carry the risk of dependence. And again, we think this has to do with the dopamine system. Drugs that enhance dopaminergic activity tend to have a higher risk for dependence. So we'll talk more about dependence at the end of this lecture. But cocaine, amphetamines, nicotine, these are all addictive substances. And they tend to be more addictive than things like caffeine, the depressants to a certain degree, Certainly the hallucinogens do not seem to work with dopamine, and they aren't very addictive. Uh, but some of the stimulants are. And so that is one of the negative consequences of long-term use. Okay, the next class of drugs are the opioids, which again, your book calls narcotics. I'm not going to use that term. But the opioids is a general class of chemicals. Now, some quick terminology, because there are some terms that sound similar but actually mean different things. For example, the term opium. This is the original form of the drug. It's been known for thousands of years, and it comes from the opium poppy, which we see here. So this is a flower. When it is about to bloom, in order to cultivate opium, one slices that pod, and this oozy substance will come out, and that is pure opium. And opium has a mixture of psychoactive components, has some other things in it as well, but it has a couple of chemicals that are psychoactive. But that mixture, that naturally occurring mixture, is opium. There are the opiates. Those are the individual chemical compounds that you find in opium. So things like morphine, codeine, which are drugs you may have heard of. Those are the opiates. So those are the naturally occurring components of the mixture opium. And then finally, there are opioids. And opioids is a much broader category. Opioids includes the opiates, but it also includes chemically related compounds. So some drugs are modifications of opiates. But also drugs that act like opiates are also considered opioids, even if they aren't that chemically similar to the opiates. So some history. As I mentioned, opioids have been known for thousands of years, at least in the form of opium. So these come from the opium poppy, which is a flower that originates in Central Asia. So it's thought that opium cultivation first started in Central Asia, but it was known in neighboring regions fairly quickly. So the ancient Greeks knew about opium. Uh, People living in India knew about opium. Certainly people in the Middle East knew about it. So there's the opium poppy. And the opium poppy has an interesting history because wars have actually been fought over opium. In the mid to later 1800s, Britain fought a war against China because essentially China had products that Britain wanted, but Britain didn't have anything that China wanted. And so they wanted to trade, but Britain needed something to trade with. They had all of these opium poppy fields, thanks to their colonies in India. Uh, but China had banned opium imports. Britain actually fought a war with China in order to gain access to the Chinese market so they could sell opium and get Chinese goods in return. Unfortunately, France and the U.S. had a small part in this war as well. Um, but it just goes to show that drugs are not just agents for recreational use and in medicine, they're also economic agents as well. And with advances in chemistry in the late 1800s, we started being able to purify the components of opium and also to create chemically related compounds. You may not know this, heroin, which we see here, heroin is actually a brand name. So heroin is a brand name of the Bayer company, the same people that make aspirin today. So they also developed heroin, which is a slight chemical modification of morphine. Morphine is an opiate. It naturally occurs in opium. So heroin was originally marketed as a medicine. It is, of course, now illegal in the U.S., but it is a potent painkiller. After these advances in chemistry, after we had these different opioids, regulations started to come into place that made some illegal, some hard to obtain, and many are obtainable only through a doctor's prescription. And prescription opioid abuse is an increasingly common problem in the U.S. So it's not just the historical picture of opium dens or heroin users. Opioids are legitimately prescribed, but they're still at the risk for abuse. So what do opioids do? Well, they mimic naturally occurring compounds in the body called enkephalins and endorphins. And these are compounds that the body makes. And these compounds bind to what are called opioid receptors. Now, of course, we didn't evolve these receptors in response to opioids. We evolved them to work with enkephalins and endorphins. It just happens that opioids were evolved by the opium poppy as a defense mechanism, and they work on the same receptors. The main effect of opioids is what is known as analgesia, which means a reduction in the perception of pain. So these are painkillers. They do have some side effects. They can cause drowsiness. Of course, if opioids are taken in too high a quantity, they can cause depression of physiological processes to such a degree that the person dies. They can cause respiratory arrest. They can also cause digestive symptoms. So you have opioid receptors in your intestines and your digestive system, and in addition to binding to the opioid receptors in your brain, opioids will bind to receptors in your digestive system and keep your digestive system from moving food along. So it can have digestive consequences as well. There are medicines to counteract those digestive symptoms so that the person can stay on opioids and reduce the perception of pain. You can counteract overdoses with drugs such as naloxone. Naloxone is just one drug that counteracts opioids, but it is a powerful one. If someone is overdosing on opioids, you can administer naloxone and they will quickly wake back up, become active, and so on. So there's a controversy as to whether naloxone should be publicly available. Some people say, well, yes, if I can have this substance around and it prevents death by overdose, why not make it publicly available so that people can get it if they need it? Other people say, well, if you make this naloxone publicly available, that will increase opioid use because it won't be as risky anymore. The jury's still out on which of those sides is correct, and they could, of course, both be correct. Our next class of drugs is the hallucinogens, and these are chemicals that alter perception in some way. Now, typically, this is visual perception, and we might say they produce hallucinations. Technically, what they do is alter perception. So hallucinations are things that aren't there. So in schizophrenia, people have auditory hallucinations. They hear voices that don't exist. With hallucinogens, it is more generally the case that visual perception of existing things is just altered. Things look different. So it's not creating objects out of thin air, so to speak. It's just altering what's there. But that's not a distinction we're going to belabor much here. And these drugs often mimic serotonin. And that might seem strange a little bit. We just talked about how serotonin is involved with mood and body temperature. So why would it cause these alterations in visual perception? Well, the fact is that you have special serotonin receptors in your visual cortex. So your occipital lobe, as we know, houses your visual cortex, and you've got a lot of brain tissue devoted to processing visual stimuli. And there are a lot of these special serotonin receptors in your visual cortex. So by activating them, hallucinogens change how visual stimuli are processed. And historically, these hallucinogens are often naturally occurring. Not all of them are, but many are. And they have often found their way into religious ceremonies. People have a sense of connection to other people or the world around them when they take hallucinogens. They may experience an increase in spirituality when they take hallucinogens. And so these have often been incorporated into various religious ceremonies. There are, in fact, legal allowances here in the United States for Native American groups that use certain hallucinogens in their religious practices. And that's another interesting controversial topic. We have religious freedom, but we also have regulations on psychoactive substances. Which of those takes precedence when they're in conflict? So that is an ongoing debate. So some hallucinogens, there are some famous ones. The most famous is probably lysergic acid diethylamide, otherwise known as LSD or just acid. And this is a synthetic hallucinogen. developed early in the 20th century, and it is a very potent hallucinogen. The required dosage to get an effect is very small. There are other hallucinogens as well. There is the compound mescaline, which is found in the peyote cactus and is one of the substances that's allowed for religious use. So this is found in the southwestern United States and Mexico, and it is a small cactus that contains this psychoactive drug, mescaline. There's also psilocybin, a different compound, but also a hallucinogen, and it's found in certain species of mushroom. These are often referred to as magic mushrooms or just shrooms. There's, of course, nothing magic about them. They just happen to contain the drug psilocybin, which again binds to serotonin receptors and alters visual perception. So what do these compounds do? Well, one thing they can do is produce something called synesthesia. And this is a merging of sensory inputs, so to speak. And there are people who are naturally synesthetic that don't require hallucinogens to experience this phenomenon. And synesthesia, if a person has it, can often result in, again, a merger of different kinds of stimuli. So one of the most common ways for this to manifest itself is that numbers will be associated with a certain color. So they can all be written in the same color, usually black, and yet someone with synesthesia will say that 4s seem red or that 7s seem orange. There can also be crossover with taste. So certain stimuli can seem salty even if they're visual stimuli, which is really interesting. So you have a crossover between different modalities of the senses. But this can be one effect of these hallucinogens. So people can have their visual perception altered on the basis of sounds that they're hearing. So their visual perception may pulsate in time with a sound. And so that would be an example of synesthesia. One sense is being altered by input for another sense. There's a big role of expectation for hallucinogens as well. So we talked about alcohol and the expectancy theory. So hallucinogens have another big intersection with expectation. People that are expecting a good experience, a pleasant one, often have that. People that are expecting a bad experience or don't know that they're on a hallucinogen can have what's known as a bad trip or a bad experience. And there was an array of unethical research done in the middle of the 20th century looking at bad trips, looking at the effects of hallucinogens on people who didn't know they were taking them. There were a lot of negative consequences. The experiences themselves were unpleasant. Some people who didn't know they were on these drugs thought they were losing their minds. And so a variety of ethical problems with that experiment. And so things like that shouldn't be done today. But it just highlights the fact that expectation plays a big part in the experience with hallucinogens. Hallucinogens typically are at a very low risk of overdose. There effectively is no lethal dosage of LSD, for example. Technically, you can have a lethal overdose in LSD in rats, but it takes such a massive amount that it's unlikely that a person would take such a large amount. That being said, there can be psychological after effects of hallucinogens, but generally not lethal. So on the safer end of the spectrum. They also tend to be at a lower risk for dependence. So people do not generally become addicted to hallucinogens. Your book mentions that rats will not self-reinforce for hallucinogens. They will for things like cocaine. So a rat, if you give it free access to cocaine, will take as much cocaine as it can, whereas they will not continue to use hallucinogens. So there's a lower risk for dependence. Part of that, we think, is that hallucinogens don't interact with the dopamine system to the degree that stimulants do, for example. And so they tend not to be as addictive. Our final kind of drug is marijuana, which again is a popular topic here in Colorado, given our recent legalization of it. A little bit of the history of marijuana. It's also known as cannabis, that is the name of the plant. And its psychoactive properties have been known for a long time, for millennia. And so it has been used like opium has, like alcohol has, for thousands of years. In the early 1900s, here in the US, there started to be the regulation of marijuana. And drug regulations are a fairly new phenomenon. They didn't start to appear until the late early 1900s. Before that, there really weren't regulations on drugs. They were sort of at the risk of the user. But these things started to be regulated, and marijuana is one of these things because it's naturally occurring in the 1900s. And so marijuana is what is known as a Schedule 1 substance at the federal level, which says that it is at risk for dependence and has no medical use. Uh, Information is starting to contradict both of those assertions. So a lot of people question whether marijuana should be a Schedule 1 substance. Schedule 1 is the most dangerous class of drugs. Not even cocaine isn't even on Schedule 1; it's a Schedule 2 substance. So the schedules on which drugs are found uh, is a matter of some debate. Part of it's evidence based, part of it's historical. Of course, here in Colorado and in other states as well, uh, there's been recent legislation to decriminalize or even legalize marijuana. And there are trends over the last few decades in the U.S. that are interesting. So, for example, many people think that reducing the availability of a drug will decrease its use, that use is a function of availability and therefore price. When in fact, at least in the case of marijuana, the use of marijuana seems to be more correlated with the perception of riskiness. So marijuana use was uh, at a very high level in the late 70s. It reached a minimum in the 90s, and it is, of course, on the rise again. And that is correlated inversely with the perceived riskiness of its use. So people in the late 70s thought marijuana was pretty harmless. People in the early 90s thought it was more harmful. And now people think it's not as risky again. And that seems to have a lot to do with trends in usage. Its legality, of course, is another important factor. So marijuana is naturally occurring, and like opium, it has several psychoactive components. The most famous and the most prominent of which is tetrahydrocannabinol, otherwise known as THC. But there are a couple others as well, like cannabidiol and cannabinol, and these are structurally related compounds, and they have different effects. So a lot of the psychoactive experiences that a person has with marijuana are a function of THC. But these other compounds uh, also have depressant-like effects or pain-reducing effects, and so they're worth considering also. And there's a lot of research being done on the different components of marijuana, because again, each of these components is similar structurally, but technically different, and so they have slightly different effects. And so possible medicinal uses might emphasize one compound over another. So what are the effects of marijuana? Well, depending on dosage, you can get euphoria. You can also get relaxation. And some sources will classify marijuana as a depressant. Um, your book doesn't. I typically don't, because it has some stimulant-like effects, like an increase in heart rate. But there are cannabinoid receptors. There are special receptors in your brain for these chemical compounds. And again, like the case with opium, it is not the case that the brain evolved receptors for marijuana. There are naturally occurring compounds in the body that look like THC. And so it's really those compounds for which cannabinoid receptors have evolved. And the compounds of cannabis itself have just sort of hijacked that receptor system. Uh, some of these compounds have an important effect on pain and appetite. They reduce pain and increase appetite, which is particularly important in terms of medical research for cancer patients. Cancer patients undergoing chemo often have pain, and they often have a loss of appetite due to treatment. And so marijuana has been investigated as being used to treat both the pain and the loss of appetite. Marijuana, there's actually never been a recorded fatal overdose on marijuana. So its overdose risk is negligible, which again makes us wonder if Schedule 1 is the appropriate location for it. So there's a negligible overdose risk. In terms of dependence, your body cannot become physically dependent on marijuana. It doesn't seem. There are arguments for psychological dependence on marijuana. We'll get to that here in a minute. Of course, marijuana is often put forth as a gateway drug. And the idea is that if you start using marijuana, that you will eventually use other harder drugs like cocaine or heroin. And there's really not much evidence for that hypothesis. Are these things correlated? Sure. But it seems to be the case that people, depending on environment and genetics, will be at increased risk to try any drug. The order does not seem to depend on marijuana being first and encouraging later drug use. So marijuana use is not causative of other drug use. It's just correlated. If you're going to try one drug, there's a tendency for you to try other drugs as well. When it comes to long-term use, we've already talked about some of the effects of long-term use of these drugs in terms of health. Things like the use of alcohol, the use of stimulants. But there's also the concept of dependence. So there are different kinds of dependence. One of them is physical dependence. And I don't like the way your book describes physical dependence. It describes physical dependence as the phenomenon of having effects when the drug is not being taken anymore. Those are really withdrawal symptoms. Physical dependence is not the same as withdrawal. Physical dependence is the phenomenon by which the body has become so used to the drug being present that you get withdrawal symptoms if the drug is removed. But even if you're taking the drug, you can be physically dependent. If you take the drug away and you get those withdrawal symptoms, again, they are usually the opposite of whatever the drug does. So if you are physically dependent on opioids, your body and brain have gotten used to their being there. If they are taken away, your body and brain are now compensating for a chemical that's not there. So instead of the pain-killing effects of an opioid, you can become hypersensitive to pain. We mentioned alcohol. Instead of getting relaxed by alcohol, you can develop anxiety when it's taken away if you're physically dependent. So there's a difference between physical dependence and withdrawal. But physical dependence is the state under which your body has gotten used to and has started compensating for the presence of the drug. There's also psychological dependence, which is a psychological need or craving for the drug. And this usually means it's hard for the person to stop using it, not because of physical symptoms, but because they simply want to take the drug, or they feel a need to take the drug. They feel compelled to take it. So those are different. And drugs can have psychological dependence without having physical dependence. Usually, if they have physical dependence, if you're at that point, you'll be psychologically dependent as well. But marijuana, for example, does not seem to produce physical dependence, but can produce psychological dependence. The word addiction can be hard to define, so it is not as scientific a term. We can refer to drugs as being addictive. What we really mean there is they're at risk for dependence. Referring to someone as an addict, or saying that they are addicted, or referring to addiction, scientifically is hard to define. How would you define it? Is it frequency of use? Well, frequencies differ from drug to drug and from person to person. And they also, of course, interact with the amount you're taking. So, dosage. What about how much control you have over your drug use? Someone may use drugs frequently, but voluntarily they may be able to stop taking them if they want to. Another person may take them just as frequently or less frequently and yet feel compelled to do so. So there are different components to addiction, and it's very hard to define that term. So I generally avoid it. And dependence is not a sure thing. So there are plenty of people who use drugs that do not become dependent on them. Certain drugs are at higher risk for dependence, so the stimulants, for example. Cocaine tends to carry a higher risk for dependence, but you have a rate of 60% if someone starts taking a drug irregularly, that they will become a long-term user over their lifetime. But for other drugs, it could be as low as 20% or 10%. You could be a heavy user of a drug for months or a year and then have no trouble stopping. So dependence is not guaranteed, and it depends on the drug as to how likely dependence is. Again, dopamine is a frequently involved neurotransmitter here. So drugs that enhance dopamine, like stimulants, tend to be more addictive than drugs that don't, like the hallucinogens. There is the phenomenon of drug tolerance, and that describes the case when a person needs an increasing amount of the drug to get the same physical or psychological effect. And there are different reasons for why tolerance develops. We're not going to go into them. But basically, your body gets used to the drug being there, and it's better at breaking it down, or your neurons just aren't as sensitive to the drug anymore. So you need to have a larger amount to get the same psychological effect. And this can be dangerous because different actions of the drug may be associated with tolerance or not. So you may take a larger amount to get the psychological effect, but the effects on respiration or the heart may not have the same tolerance. And so tolerance can be dangerous and is often a sign of physical dependence. So how do we treat dependence once someone is dependent on a drug? Certainly there are social interventions and therapies, group therapy. One of the most famous is, of course, Alcoholics Anonymous, which we see here. And these are non-pharmacological. These do not involve administering a chemical to get over drug dependence. And they are moderately effective. Drugs also are moderately effective, and they're often used in combination. So you can apply a similar drug to the one that the person is dependent on, or a drug that does the opposite. If you apply a similar one, it's often to wean the person off of their drug of choice. So a famous one here in the lower right is methadone. Methadone is often used to treat opioid and in particular heroin dependence. So methadone in many ways is safer. Methadone is itself an opioid. So you're really just swapping out one opioid for another, which is why methadone treatment is controversial. You can also apply opposing drugs. So naloxone is an example. If someone has naloxone in their system, opioids won't have any effect. So you're removing the rewarding properties of the drug by blocking it with an opposing drug. So that's another way to treat drug dependence. This can often be unpleasant, though, because it can exaggerate withdrawal symptoms. Alcohol is another substance that's at risk for dependence. And to wean someone off of alcohol, again, the withdrawal can be lethal. So you'll apply a similar drug, usually a benzodiazepine like Valium. And that will substitute for the alcohol temporarily, and then you can wean the person off of the benzodiazepine. Some more interesting and newer approaches are to alter the metabolism of the drug or even to generate an immune response. So they've been developing essentially what is a vaccine for cocaine, to where the immune system will bind to cocaine and prevent it from getting to the brain. So it's a very interesting approach. The person can take potentially even large amounts of cocaine and not feel anything because their immune system has attacked it. And that, of course, is a new and interesting approach, but it depends on the person volunteering for the immune treatment. You can also alter the metabolism of a drug. One popular way of treating alcohol dependence is through the drug disulfiram, otherwise known as Antabuse. That's its brand name. And what this does is keep alcohol from being broken down into later chemicals. So there's a metabolic pathway for breaking down alcohol. And if you interfere with it, you start to build up these different chemicals very quickly. And these chemicals will make you nauseous. It makes drinking alcohol very unpleasant very quickly. And so antabuse interferes with the breakdown of alcohol and makes the person feel sick when they drink it. Of course, that depends on the person consistently taking antabuse. So it depends on the behavior of the user. But it is another potentially useful treatment. Okay, that will do it for our unit on psychoactive drugs. Uh, by the way, if you found this unit interesting, if it's something you'd like to study more of, we actually offer an entire class in the department on psychoactive drugs, behavior, and society. So you may want to look into that. Next time, we'll start to look at consciousness. And consciousness is the kind of thing that we all have, but if you ask someone to describe it, it's very difficult. So it's a hard thing to define. It's also a really hard thing to measure. So we all say that we're self-aware. We think other people are self-aware and are aware of their own minds. Uh, but how do you study that? How do you measure awareness? How do we define the properties of consciousness? What makes a person conscious and another person perhaps less so if they're in a coma or asleep? So there are levels of consciousness. There are properties of consciousness that we think define it, and we'll also talk about uh, animals and what properties animals might have when it comes to consciousness. And of course, we're not conscious of everything. We're not aware of everything going on in our minds or our brains. So there's also the unconscious mind. So we'll talk about that as part of that unit as well. And I will see you all then.